Hello everyone, I am Smriti Sinha here, and today the topic that we are going to study is acidity and basicity trends to electron displacement effect. So what is happening due to electron displacement effect to the acidity and basicity of the molecules? So we have seen in the last class what is exactly electron displacement effect and how does it occurs. Today we will see its effect on the acidity and basicity of molecules, the theory part of it, and then we'll move towards the practice MCQs. So let's begin. What is acid? So what is acid? Any substance which give H plus ion in the aqueous solution, or any substance which donates its H plus ion, or any substance which accepts the electron is called as acid. Okay, so this is according to the Arrhenius theory, this is according to Lorentz theory, and this is according to the Lewis theory. Now what is base? Base is any substance which donates OH minus ion in the solution, or base is any substance which accepts H plus ion from the other substance, or base is any substance which donates electron to the other substance. So this is according to the Arrhenius theory, this is again according to the Lorentz theory, and this is according to the Lewis theory. Now how do we explain the strength of acid? Whether my acid is strong or weak acid, how do I explain it? I will explain it on the dissociation of the proton, how fast the H plus can dissociate from the A minus ion if my acid is Ha. And for the strength of base, I will explain according to how fast my OH minus ion can dissociate from B plus if my base is BOH. And this is how I can explain the strength of acid and base. So first effect that affects the strength of acid and base is element effect. Hi Sanjay. To move towards the element effect. The first effect, electronegativity. Hi Avintika. So we are going to see today the first, that is electronegativity. Now, how does electronegativity affect this strength? For this, I will take one example. First, consider ethane. Ethane, and then with it methylamine, and then with it ethanol. So what is happening with ethane, methylamine, and ethanol? So remember, here what happens is that here if you see that acidity goes on increasing, if you move from here to here, the acidity is increasing. Now why do I say that the acidity is increasing if I move from here to here? So the thing is, what is happening is, if you see what is acid, acid is any substance which is going to donate the H plus ion. Okay, so if it donates the H plus ion, it will be get converted to the conjugate base. So after donating the ion, they get converted to the conjugate base. Similarly, this one will also get converted to its conjugate base. And similarly, ethanol will also get converted to the conjugate base. Okay, so ethane, methylamine, and ethanol, all of these three are getting converted to the conjugate base. But the conjugate base of ethanol is more stable. As it is more stable, it easily loses its H plus. Okay, so the conjugate base which is more stable will lose its H plus very easily, and therefore it easily loses its H plus to be converted into acid. Okay, so that's why ethanol is a strong acid as compared to others, because it want to be stable, it want to be forming the stable conjugate base by losing its H plus. and rather than methylamine, which is an intermediate in basic character than ethane. Now, why ethane is less basic? Because its conjugate base is very less stable. And as it is very less stable, it won't let its H plus to go out, and therefore it won't form the acidic character, that is the conjugate base. So what is the main reason behind this? This is the first thing, that its conjugate base is more or less stable. According to that, the acidity is decided. So, yes, Avantika. So the connection between the electronegativity and acidity can be explained in the way that higher the electronegativity of any atom, more it can accommodate the negative charge on it, that is, more it can accommodate the negative charge as conjugate base, and because of that, this conjugate base can get well stabilized, and hence it can lose its H plus easily by stabilizing its conjugate base, and stronger will be the acid. So remember, more stable the conjugate base, weak will be the conjugate base, but stronger will be its acid, because it will allow the H plus to lose easily. Next is the size of atom. So how does size of atom affects my acidity or basicity? Here we'll compare some acids, that is HF, HCl, HBr and HI. Okay, now we'll talk about the conjugate bases, because after losing the H plus as they are acid, they will form conjugate base, that is F minus, Cl minus, Br minus and I minus. Now talking about the acidic character, so acidic character moves towards the right, it is increasing. If you are moving towards the right, the acidity is increasing, and if you are moving towards the right for conjugate base, the basicity is decreasing. Now why basicity is decreasing? Because the main reason over here is that I minus is a stable conjugate base, and as it is stable conjugate base, it won't let this minus charge go. Okay, now why I minus is more stable than F minus, even though all are electronegative atom? Because now here the size matter. The size difference between the H and F is not much, therefore they can form a stronger bond. As they can form a stronger bond, the F won't let H to go, and that's why it is a weak acid. But for HI, the size difference is much more, because I is larger and H is smaller. Bond between these two different sizes, the H to go and be donated as an acid, and that's why HI behave as a stronger acid as compared to HF. So if you see in this table, fluorine size is smaller than chlorine, chlorine is smaller than bromine, and bromine is smaller than iodine. And so the sequence of the acidity too. The larger atom, the more the acidic character. So if you move vertically in the same period of a periodic table, you will see the size of the atom is increasing, electronegativity is decreasing, and that's why the atomic radius of iodine here is almost twice of that of fluorine. And the reason is that why iodine ion has a negative charge more spread over it, like a large molecule, large atom have a small charge over it. So this negative charge can be well spread over here in case of iodine, but in case of fluorine, the size is small and the negative charge will get less space to be spread, and therefore this will be unstable. So F minus ion is unstable because its size is small, but I minus is stable. As I minus is more stable, it is less basic but more acidic. Next is resonance effect. So what does resonance effect does to our molecule? So the species that has more resonating structures will show more stability. Okay, so the more the resonating structure, it will show more stability in the conjugate base, and that will be more stronger acid. So here we will compare ethanol and our acid that is the acetic acid. So we'll draw first acetic acid. This is acetic acid, and we are going to compare it with ethanol. Now both are acids, so suppose both donate its H plus. Okay, now both has donated its H plus, but this ethoxide ion is a weak acid, or it is a non-unstable conjugate base. It is unstable conjugate base. It is unstable conjugate base, and therefore it is a strong base. Because it is unstable, so it will try to find out the H plus very quickly and try to act as a strong base. But this acetate ion is a stable conjugate base because of resonance. And more the resonating structure and more the resonance, more is the stable conjugate base. And if the conjugate base is more stable, it is a strong acid. So therefore, acetic acid is a strong acid because its conjugate base is more stable. So it will allow the H plus to go easily. Next is the resonance effect. So if more resonating structure is possible for a conjugate base, the more will be the stability, and more will be the stability, then more it will be acidic. So for this, we are going to compare our ethanol with phenol. So both have OH group in it. Ethanol and phenol both has OH group in it. Now, in both the structure, if they donate the H plus, they are going to form the conjugate base as usual. So they have formed the conjugate base. One is the phenoxide ion, one is the ethoxide ion. Now, ethoxide ion is unstable, and therefore it is highly basic. It is highly basic, but the acidic character of ethanol is weak because this conjugate base formed is unstable, so it won't allow its H plus to go out easily. But in case of phenol, the conjugate base is highly stable due to the resonating structures, and there are many resonating structures possible. So few of them I'm drawing here. So as it has many resonating structure possible, so it forms a stable conjugate base, and as it forms a stable conjugate base, it will allow the H plus to go out easily, and therefore phenol is a acid. You can say it is a weak acid, but the ethanol is neutral in nature. Next is the inductive effect. So what happens due to the inductive effect to the acidity? So inductive effect actually is an effect which operates through a sigma bond, and which is the charge dispersal effect of electronegative atom through sigma bond. Okay, so if you see, the more the number of the electronegative atom, more will be the inductive effect. So let's see example for this. So the first example is, if you have acetic acid with you, and if you have monochloroacetic acid, this is monochloroacetic acid, because in acetic acid I have substituted one hydrogen by chlorine. Now try to draw the conjugate base of this. Actually here both of them are stable conjugate base, because obviously due to resonance, but the second one is more stable. This is more stable. Why? Because here you have one chlorine atom which is electronegative in nature, and which is going to pull the charges towards itself, because of which the O negative, which is highly negative character it is having, it will be well stabilized due to two things. First is the resonance, and other is due to the minus I effect, and because of which this will gain extra stability as compared to this, and therefore you can say this conjugate base is less stable, and therefore monochloroacetic acid is more acidic than the acetic acid. But as the number of chlorine atom increases, the acidity also increases. Okay, so if you see, if you talk about the number of chlorine atom increasing, so compare now again acetic acid, monochloroacetic acid, dichloroacetic acid, and trichloroacetic acid. So monochloroacetic acid, the pK value over here is 4.8. For this is 2.8, for this is 1.3, and for this is 0.64. So more the pK value, less the acidity. Remember this relationship. More the pK value, acidity is less. So here you can see the less value for pK is for the trichloroacetic acid, and that's why it is the most acidic. And the reason is it has more number of halogen atom, more minus I effect, and therefore more stable conjugate base, and hence more the acidity. Next is, if you take more electronegative atom as compared to the other, that there also acidity will increase. So if you see for trichloroacetic acid and trifluoroacetic acid, which is also called as TFA because it's trifluoroacetic acid, if you compare these two, the more acidic is the trifluoroacetic acid because the fluorine atom is more electronegative than in chlorine, and therefore it is more acidic than the other. Next is the distance. For inductive effect, you need to also consider the distance, because as distance of electronegative atom increases, you will see that inductive effect reduces and acidity also reduces. For this, we will take a simple example of this molecule, comparing it with the other. Now, if you compare these two, the chlorine is here close by to the O negative charge wherever it will form, and here the chlorine is away from the O negative wherever it will be formed by conjugate base. And that's why if you see, this is more acidic because here the minus I effect stabilization to the conjugate base will be more, and here it will be less acidic because less stable, because the reason is the Cl minus ion that will stabilize the conjugate base. Here the distance is more, therefore it will stabilize less, and therefore it is less acidic. Next is hybridization effect. So how does hybridization affect our acidity or basicity? So remember, if you compare simple molecules like ethane, ethine, and ethene and ethine. So ethane, ethene and ethine, if I compare, if you see here it is sp3 hybridized, here sp2, and here sp hybridized. So here S character is 25%, here S character is 33%, here S character is 50%. Now if you draw their conjugate base, it will form okay. Now this conjugate base is more stable than the other. Why? Because the triple bonded carbon is having a negative charge, that is S character is very much more. So S character, that is nucleus, is very close by, which will hold this negative charge very strongly, and therefore this is the most stable conjugate base. If the conjugate base is more stable, it can donate the H plus very easily, and therefore it is a strong acid. So the simple conclusion is, as the S character increases, acidity increases and basicity decreases. Now we move towards the MCQ section, that is the practice questions. So the first question for today is, as per Arrhenius concept, weak acid among these is. So as I have told in the beginning of this class, what is the acid according to Arrhenius? So acid is any substance which can donate its H plus easily in the aqueous solution is an acid. So according to Arrhenius concept, see, all of them are going to donate is H plus, but the weakest among this will be. So if you see, you need to draw the conjugate base after donating the H plus, and then you have to compare them which conjugate base is less stable, and then you can understand which will be the weak acid. So all of them have donated H plus, they have formed the conjugate base. And if you see Cn minus is a unstable conjugate base as compared to other, because here the negative charge is on carbon. In rest of them, the negative charge is on electronegative atom, that is the negative charge will be more stable on electronegative atom. Therefore this conjugate base is less stable, and therefore this acid is weak acid. So answer over here is option C. Next, which of these is not an acid despite being a hydrogen compound? So which of these following is not acid even though it has hydrogen in it? So if you see clearly, you will get an idea that it is CH4, because the conjugate base over formed here is very unstable. It won't let its hydrogen be lost in any of the case, and therefore alkyl groups are very weak acid, and therefore here answer is option A. Next, as per Bronsted and Lore concept, a base is a substance that, so as I have told you, according to Lore and Bronsted concept, base is any substance which accepts H plus from the other. So answer is option A. Next, which of the following pairs does not show an acid and its conjugate base? So you need to see the pair and see which one is not a correct conjugate acid base pair. So let's see. Here HNO3 is donating one H plus and forming NO3 minus. So it is correct pair. Next is H2SO4. It is donating one H plus and forming HSO4 minus. So it is also correct pair. Okay, for next H2SO4 donating both the H and forming SO4 2 minus, this, because in the last class we have studied that conjugate acid base pair is the pair which differs only in one H plus, not in two, and here it is differing in 2 H plus, and therefore it is the wrong pair. That is option C is correct. Next, which compound is least acidic? So out of this, which one will be the least acidic? So if you know, as usual, it is always the alkyl group, that is CH4. Next, which compound is most acidic? So out of this, which one is most acidic? So you will see all of them have same structure, except the difference is fluorine, presence of fluorine, chlorine, bromine, iodine. The more electronegative atom present, the more will be the stabilize the conjugate base, and therefore it will let its H plus go easily, and stronger will be the acid. That means you need to see where more electronegative atom is attached. The more electronegative atom attached, that will be the stronger acid. So the most acidic here is option A, because here you can see a fluorine attached, which is the most electronegative element in the periodic table, and as it is most electronegative element, it can stabilize the conjugate base very easily, and then if it stabilizes the conjugate base easily, the conjugate base will be stable, won't take its H plus again, and therefore it is a strong acid. Next, which compound is most basic? So out of this, which is most basic? So if you see here, you can see NH2. NH2 has lone pair of electron. So one which can donate the lone pair easily is most basic. So if you compare all this structure, if you see in the C structure, the lone pair will be busy in resonance, so it won't be available for donation. In the D structure also, the lone pair is busy in resonance, therefore it also will be not available for donation. In the B structure, lone pair is not busy in resonance, but still CF3 is having 3 fluorine, which will be pulling the electron towards itself by minus I effect, and again reducing the basicity, that is ability of the lone pair to be donated. But in A, the lone pair of electron is not busy anywhere and it can be easily donated, and therefore it is most basic in nature. Next, which compound is most acidic? So out of this, which one is most acidic? Again, if you see, you have to compare the conjugate base. So here the conjugate base form is like this. Here also the conjugate base is stable, no doubt due to resonance, but the negative charge is on carbon. In this case also the conjugate base will be stable, no doubt, but again the negative charge is on carbon, and you know that negative charge on the less electronegative atom is less stable. In this structure, if you see, here also the negative charge will be on carbon itself, okay, but the thing is here you have OMe group also to stabilize it, and here also the negative charge is on carbon itself again, but the negative charge can be stabilized by the NMe2. So here also negative, in all the structure negative charge is stabilized by resonance like this, okay, but the thing is the other factor of stabilization is inductive effect. So in the structure A, there will be no inductive effect playing any role, in B also, but in C, if you see, the OMe will pull the electron towards itself because oxygen is more electronegative. So the negative charge is stabilized here by two reasons, due to plus R effect and even due to the minus I effect. And in D also the same thing, plus R and minus I effect, both are stabilizing this conjugate base, but the more stable one is this. Why? Because the oxygen is more electronegative, so more will be the minus I effect, more will be the minus I effect, more will be the stability, and more the conjugate base stable, stronger is the acid. Therefore here the correct answer is option C. Next, which carboxylic acid is most acidic? So out of this, which one is most acidic? So you have to see here the distance one. So I have told you while in studying the inductive effect that as the distance of electronegative atom increases, acidity decreases. So in the first one, there is no electronegative atom, so it will be less acidic. But in second, third and fourth, electronegative atom is present. But the B structure, in B structure, the electronegative atom is very close to your negative charge atom, whichever it will form when it will form the conjugate base, and therefore the B1 is more acidic because it will form more stable conjugate base, and as it can form more stable conjugate base, it is more acidic in nature. Next, which substituted benzoic acid is least acidic? So which one is least acidic out of this? So if you see in all this benzoic acid, once the H plus is donated, the negative charge will be formed on CO2 negative like this. So this will be the conjugate base formed after the H plus is donated in all of these cases, correct? Now, which conjugate base will be more stable and why? So if you see here, all the conjugate base are stable due to plus R effect because here there will be resonance effect seen and therefore they will be obviously more stable. But now you have to also see the other group which is present along with that. So if you see any group present at meta position, because this is ortho and this is meta position, any group present at meta position won't affect the conjugate base. So you have to rule out this condition for the least acidic because they won't affect. It will be as stable as benzoic acid itself. Similarly, CH3 here also is present at meta. So it won't affect the conjugate base. It will be as stable as the benzoic acid itself. So you will rule out these two options. Now left with chlorine and CH3. Now chlorine is such an atom which shows even plus I minus I effect. Okay, so it will show plus R effect. It will even show minus I effect, and therefore it will pull the negative charge of this carboxylate ion towards itself, making it more stable. And as the conjugate base more stable, it will be more acidic. So the more acidic one is this, but the least one will be D because the CH3 shows plus I effect, O is already having a negative charge and CH3 is donating more electron due to plus I effect, increasing the electron density more, making the conjugate base unstable and therefore least acidic. So your correct answer is option D. Next, which substituted phenol is most acidic? So out of these phenols, which one is the most acidic one? So again, wherever you see groups at meta position, just rule out them. This is a trick because meta position groups won't affect your molecule much. Now left with B and D, you want the most acidic one. So this is question number 12. Which substituted aniline is least basic? So out of this, which one is the least basic? That you have to choose. Now, the one which can donate its lone pair easily will be more basic, correct? So one which donates the lone pair easily is more basic. So you have to choose which one will not donate its lone pair easily, will be less basic. Now, here if you choose according to the resonance effect, all are less basic because in all the structure the lone pair is busy in resonance. But now you can see all the groups present at para position. So you have to consider the group 2 over here to understand the basicity. So if you see talk about CH3, CH3 shows the plus I effect and therefore it will try to increase the electron density at NH2 and therefore it will increase the basicity. Okay, because electron density increases means that basicity will increase. Now for structure B, it shows minus I effect, it pulls the electron, so it reduces the electron density at NH2, so make it less basic. For Cl, again it increases the electron density actually due to the plus R effect, but it decreases the electron density due to minus I effect. So both things Cl do, so we will rule out Cl over here. But for NO2, NO2 is the most electron withdrawing group and it will try to withdraw the electron from this NH2 towards itself due to minus I effect and making it less basic. So now the competition is between B and D. Which one makes the most basic? So remember D, because nitro is showing a strong minus I effect, making the NH2 group lone pair pulling it towards itself. So this lone pair is not available for donation. As lone pair is not available for donation, this aniline is least basic. Next, consider the acidity of carboxylic acids. So you have few of the carboxylic acids with you. You have to consider their acidity and then write their correct order. So if you draw the structure for all, so the first is the benzoic acid. This is A. B is orthonitrobenzoic acid. At ortho, you have to add nitro. This is B. For C, it is metanitrobenzoic acid. And for next, sorry, this is D. This is meta for D. And for C, it is para-nitrobenzoic acid. That is C. So this is C. Now, which one is the most acidic? So the one where the negative charge of the conjugate base will be well stabilized, that will be most acidic. So according to this, if you see over here, the B1 is more acidic. Why? Because the nitro group is very close to the COOH group. That means that it will more stabilize the negative charge of carboxylate ion, and as it will stabilize more the conjugate base, it will be more acidic. So B is the most acidic. Then obviously after ortho, para position nitro affects the most and therefore C is the most acidic. Why? Because it will stabilize the conjugate base. Okay, then will be your D, because at meta at least there is something present, nitro, it won't much affect your carboxylate ion because it is present at meta, but still it will show somewhat minus I effect and it will affect it. So it is next most acidic, and the least one your benzoic acid because it does not have any electronegative group attached or electron withdrawing group attached which will stabilize the conjugate base, and therefore it is the least acidic. So if you see this sequence, it matches with option A and therefore option A is correct. Next, which of the following compound is expected to be most basic? So out of this, which one is most basic? So let's draw all the structure. The first one is the aniline. The second is methylamine. Next is hydroxylamine. Next is ethylamine. So which is most basic? So one which can donate the lone pair easily is most basic. So here if you see in A, lone pair B is in resonance, least basic. Here it is basic, here also basic, but in this case the negative oxygen is more electronegative than nitrogen, so it will pull more electron towards itself and decrease its basicity. But in B and this structure, B and the D structure, the competition is there. So in B and D, obviously D wins because D has more number of alkyl group. More the alkyl group, more the electron density will increase due to plus I effect, and more will be the basicity. And therefore your correct answer is option D. Next, by the presence of a halogen atom in the ring, what is the effect of this on basic property of aniline? So if there is a halogen atom present in any ring of, means any position in the aniline molecule, how it will affect its basicity? Okay, so remember here basicity will increase because halogen atom will show plus R effect, increase the electron density somewhat, and therefore obviously the basicity will increase. Next, what is the correct decreasing order of basic character of 3 amines and ammonia? So if you compare these 3 amines and ammonia, which one will be the most basic and which one will be the least basic? So remember, more the alkyl group, more the basicity. So earlier also we have seen in the question, ethylamine is more basic, then is the methylamine, then ammonia, and in aniline the problem is the resonance. So in aniline the lone pair is busy in resonance, therefore it is least basic, and therefore the answer is option B. Next, the correct order with respect to the magnitude of negative inductive effect is given by groups. So which group will show more negative inductive effect and which one will show the least? So remember, more the oxygen atom, more the electronegative effect, more will be negative inductive effect. So see where the oxygen atom is more, obviously this and this. So option B and D is automatically ruled out. Next is SO2 with 2 oxygens, then should be SOR, not SR, because it at least have 1 oxygen, and therefore correct answer is option C. Next, what is the %X character in hybridization of carbon when it shows strongest minus I effect? So when it will show the strongest minus I effect, that will be more acidity. So what will be the S character? So remember 75%. More the S character, more is this acidity, and more it's strong minus I effect. Next, the correct order of acidic strength of given acid is. So out of this, which acid is the strongest acid and which one is the weakest? So let's compare the formic acid. This is formic acid with acetic acid, and then with propionic acid. So which one is the strongest acid? Remember, here what happens, once the H is gone, oxygen will form the negative charge, correct? Now this negative charge, if it's stable, then your acidity is more, means your acid is more strong acid because conjugate base will be stable. Now what is happening here in this and this case, once this O negative is formed, the C2H5 and CH3, that is the alkyl group, due to plus I effect tries to increase the electron density on oxygen. So oxygen is already electron rich, okay, and again because of alkyl group, more electron density is going to be increased, therefore the conjugate base will become less stable. But in the formic acid, no such problem is there, and therefore it is the strongest acid out of all because the conjugate base is well stabilized. Then the acetic acid, why? Because here only one alkyl group is there, no much effect of the plus I. And then the last one, because more alkyl group, more the effect of plus I, more unstable conjugate base, and weak the acid. So your correct sequence is option A. Next, identify the correct statement about the electronegativity of groups given below. So you have few groups given here and you need to find out the correct statement for that. So first, CF3 group has greater value than that of NF2. So this is correct because CF3, because there are 3 fluorine, it have more value than the NF2. Then NH2 group is has lower value than NF2, correct? Because here NF2 means 2 fluorine, here 2 hydrogens only, more electronegativity will be towards the NF2. Therefore, this statement is also correct. OH group has greater value than NF2. Yes, because oxygen is more electronegative here, you can say. Okay, and still it is more, here it is having the greater value. So remember now this all statements are actually wrong. Why this is wrong? If you say why it is wrong, B is correct actually, but this is wrong. Why this is wrong? Because oxygen is less electronegative than fluorine, correct? In periodic table, the electronegativity is like this: fluorine, oxygen, nitrogen, then sulfur. Now oxygen is less electronegative, that means NF2 should have greater value than OH, but here OH is showing greater value, so this is wrong. Okay, this one is correct as I have told you. Now here 3F is there and 2F is there, so 3F should have greater value. Okay, but the thing is here carbon is there and here nitrogen is there, so which one will have more value? Okay, nitrogen obviously. So the combination of nitrogen and fluorine will have more value than combination of carbon and fluorine. So this statement is wrong, this statement is wrong. Now moving towards the D statement, CH3 and C2H5 groups have almost similar value. So what is about, see this and this is wrong, this is correct. Now CH3 and C2H5 group has almost similar value, this is correct because both are alkyl groups. Okay, and both groups have only carbon and hydrogen in them, so no much difference of electronegativity, and therefore here the correct statement is B and D, that is option D. Next, which of the following is an incorrect statement about inductive effect? So about inductive effect, which statement is wrong? So first, the electron withdrawing inductive effect of a group weakens the OH bond in COOH group and favors ionization of carboxylic acid. So actually it not means you have to say that what happens over here is actually like this. So this is the carboxylic group, and if you have any electron withdrawing group attached to it, the carboxylate ion formed over here, that is the O negative charge, will be well stabilized due to this chlorine, that is due to minus I effect, and as it is well stabilized due to minus I effect, this carboxylate ion will be well stabilized, that is conjugate base well stabilized, stronger will be the acid and weak will be the OH bond. And that only they are saying that OH bond in this becomes weak due to the minus I group present and strong will be the acid. So this statement is correct. Next, it operates through space. False. The inductive effect do not operate through space. Hyperconjugation operates but not inductive effect. Next, aniline is weaker base than ammonia. Correct, because aniline lone pair is busy in resonance, so it is a weaker base than ammonia. Next, alkyl groups are good example of positive inductive effect. Correct. So only the wrong statement is option B. Next, assertion. Benzyl amine is more basic than aniline. This is your assertion. And the reason, NH2 group is electron releasing group. Now, if you see here, benzyl amine, this is benzyl amine, okay, and this is aniline. Now, benzyl amine is more basic than aniline. Actually, this statement is correct. Why? Because in aniline, the lone pair is in resonance and hence the lone pair cannot be donated easily. So it is a weak base. But in benzyl amine, the NH2 cannot be in the resonance. Why? Because the CH2 or that is sp3 hybridized carbon comes in between, and therefore no resonance. So this lone pair is easily available for donation. So your assertion is correct. That is benzyl amine is more basic because the lone pair is available for donation. Reason, NH2 group is electron releasing group. Correct. The NH2 group is electron releasing group and therefore it shows the basic character. So your assertion and reason both are correct, and reason is the correct explanation for assertion, and therefore option A is correct. Next, assertion. Dimethylamine is a stronger base than trimethylamine in aqueous phase. Okay, so what they say that dimethylamine it should be methyl. So it is dimethylamine is a stronger base than trimethylamine. This is trimethylamine. So correct dimethylamine is yes, the strong base than trimethylamine. Now you will say that the plus I effect is more in trimethylamine. So this should be a strong base, not the dimethylamine. Okay, but the thing is here there is steric problem. And due to steric problem, the triethylamine becomes weak base than dimethylamine. And the reason is given here. Due to steric hindrance in trimethylamine, the lone pair available for donation is decreases on the nitrogen atom, and more inductive effect of CH3 group. Means even though there is more CH3 group, more plus I effect, then to the lone pair available for donation is less because of the steric problem, and therefore it is less basic. This assertion and reason is both are correct. Therefore assertion and reason are true, and reason is a correct explanation for your assertion. Next, assertion, para-chlorobenzoic acid is stronger acid than benzoic acid. So we draw the structure, para-chlorobenzoic acid is stronger acid than benzoic acid. Okay, now chlorine has electron donating resonance effect. So yes, para-chlorobenzoic acid is a stronger acid than this. It is very true, but chlorine has electron donating resonance effect. It is not correct explanation over here. Actually, the correct explanation is chlorine has minus I effect, which stabilizes the conjugate base. So your assertion is correct. Okay, but the reason is also correct, that chlorine shows more plus R effect, but reason is not correct explanation for assertion, because for assertion the reason is actually minus I effect, not plus R effect. Because if it shows plus R effect, it will unstabilize its conjugate base and weaken the acid. But due to minus I effect, it stabilizes the conjugate base and make the acid more acidic. Therefore, here assertion and reason both are true, but reason is not correct explanation, and therefore option B is correct. Next, assertion, HCLO is stronger acid than HBro. Okay, so correct reason, see, greater is the electronegativity of halogen, greater will be the attraction of electron pair towards it, and hence more easily H plus ion can go. So what they are saying, that if HClO loses its hydrogen, so it will form this. Here also HBro loses its hydrogen, so it will form this. The more electronegative atom, more it will stabilize the O negative charge, more will be the strong acid. So here, yes, correct, this HClO is a stronger acid because Cl is more electronegative, and therefore it will stabilize the conjugate base more, and it is more acidic. And the reason, that is greater the electronegativity of halogen atom, greater will be the attraction of electron pair, and easily it will let the H plus go, and stronger will be the acid. So assertion is correct, reason is correct, and reason is the correct explanation for assertion. Therefore option A is correct. Next, assertion, electron withdrawing groups decreases the acidity of carboxylic acid. So if electron withdrawing group is present, the acidity of carboxylic acid will decrease. Reason, substituent affect the stability of conjugate base and acidity of carboxylic acid. So you know that as electron withdrawing group is attached, the acidity will increase, not decrease, because electron withdrawing group will show minus I effect. As they show minus I effect, they will stabilize the conjugate base and acidity will increase. Okay, so assertion is false. Reason is correct actually, because substituent affects the acidity of any acid by stabilizing or unstabilizing the conjugate base. So reason is true, but assertion is wrong. Therefore option D is correct. Next, assertion, ortho substituted benzoic acids are stronger than benzoic acid. Okay, so they say that ortho substituted benzoic acid is stronger. That is very true, because that benzoic acid will be more stabilized, conjugate base will be more stabilized, and it will be more acidic. The reason, ortho substituted trends to prevent coplanarity of COH with ring, hence reason is diminished and acidity increase. Correct. So this is called as ortho effect. Actually, ortho effect, what is that? Ortho effect says that if you have any ortho group present, due to the steric problem, the CO2H group will lose its planarity, means it will be not in plane with the benzene. So resonance will decrease and therefore it can donate its H plus easily, and therefore it will be a stronger acid. This is called as ortho effect. So your assertion reason is both correct. Reason is the correct explanation for assertion and option A is correct. So that's all for today. Thank you. If you like my video, please give it a like, share this video with more and more of your friends, and please subscribe my channel. That's all for today. Thank you. Stay tuned.